Hello everyone. For this week's tutoring video, I'd like to discuss the mechanics of the tension force and how to solve common problems involving such a force. Tension refers to the force acting along any long and slender object, such as a rope, a wire, or a cable, a group of wires. Tension is applied along the length of the object, which is also stated to have been applied axially, i.e. along the axis of the object. The most basic of these tension forces is straight down, with an object attached to a rope or rope-like device like this. And the only force acting on the object, ignoring air resistance, is its mass times gravity. And so, when the object that endures tension is pulled to its maximum length, it will experience a tension force equal and opposite to the mass times gravity. Note that in real-life applications, different materials will support different amounts of tension before snapping. None have an infinite amount of support. And as a general rule, different ropes made out of the same material will support more tension before snapping, the thicker the rope. Which is why many heavy-duty ropes, like climbing ropes, are braided to get the maximum thickness possible. If the object happens to be accelerating back upward, for example if you push it, by its mass times upward acceleration, then the tension force will subtract this mass times acceleration upward, as they are in opposite directions. The next example is more complicated, but also more realistic, and states that, with multiple tension forces acting on one solid object, what would the tension forces have to be to keep the object suspended and not falling from gravity? A little like this. The first thing to do is state tension 1 and tension 2, and then the weight, so we know the basic forces in this diagram before we break it down further. We know by Newton's third law that the net force would have to be 0, aka the summation of forces equals 0, for the object to not be moving. We can break this down further into the x and y components because forces are represented with vectors. We know off the bat that they add up to 0. However, we would like to find the individual forces and not simply their sum. We first measure the angle of tension 1 and tension 2 with respect to the ceiling they are tied to. And state that tension 1 times cosine theta 1 plus tension 2 times cosine theta 2 equals 0. We do not add up the weight, however, as the weight is vertical only and therefore automatically has a horizontal component of 0. We now add up along the other axis and state tension 1 sine theta 1 plus tension 2 sine theta 2 plus weight equals 0 and equals the summation along the y-axis. We can state that tension 1 and tension 2 are equal to weight equals mass times gravity and magnitude. But because tension 1 and tension 2 are at an angle, their actual force is different than their ordinary magnitude. Therefore, we can break this down so that the summation along the y-axis is now equal to mass times gravity times 1 plus sine angle 1 plus sine angle 2, as mass times gravity is a constant factor along all the components. And by similar logic, we can break down summation along the x-axis to mass times gravity times cosine 1 plus cosine 2. And so the only variables we need to know are the mass of the object that is hung and the angles of the ropes relative to the ceiling they are fixated on. As something like gravity is a constant, as well as the obvious factor of 1 along the y-axis. Now that I've shown how tension forces work, I can move on to mechanical devices that utilize tension forces, starting with the pendulum next week and then moving on to the pulley the week after that.